Hey everyone, welcome to ALB programming lesson. As we know, short message field of a single PDU cannot be larger than 255. In reality, the allowed size of each SMS may be even smaller than 255. Typically, 140 is the limit. If you want to send longer SMS, you can use message payload field of a PDU. Data size can reach up to 64K. We learned that in the previous lesson. In this lesson, we will learn another common approach to send long message, which is concatenated SMS, or CSMS. Typically, one SMS contains up to 140 characters, assuming all characters are English characters. When a message is longer than 140 characters, let's say 141 characters, we can split it into two SMS. The first part, taking 134 characters, and the second taking 7 characters. As we know, SMS can carry 140 characters. The first 6 characters contain what is known as user data header, and the remaining 134 characters are allocated to SMS content, which is the case in the first SMS. In this example, the second SMS, the first 6 characters also has to be the user data header, and the rest is the message content. These two SMS are intended to be one message originally. But because SMS has its own limitation, one message is split into 2 SMS parts. Then all SMS parts will be sent to the SMS center. Then SMS center delivers all those SMS parts to the recipient's device through mobile network. Each SMS part has what is known as user data header. The very header keeps the SMS part in order so that the original message will be correctly recovered from the SMS parts in the recipient's device. So what exactly is in that user data header? There are 6 fields in it, typically. Each field takes up 1 byte. The first field is the length of the user data header. We need to add up the length of the second field, third field, fourth, fifth, and sixth field. Usually, it is constant and equal to 5. Skip the second field, we'll come back soon. The third field is the length of subheader. You need to add up the length of the fourth, fifth, and sixth field. Typically, the third field is a constant and equal to 3. Alright, the fourth field is pretty much a message ID. It identifies which SMS part belongs to which message, so that different messages will not be mixed up in the recipient's device. This message ID ranges from 0 to 255. The length of fourth field itself is 8 bits. If you think this many message ID is not enough for you, then you can use 16-bit reference number. Then you have over 65,000 message IDs. Now, it is time to come back to the second field. It's equal to 0 if you use 8-bit message ID. But if you use 16-bit message ID, then the first field will be changed to 6, and the second field to 8, and the third field to 4. So, the second field is called Information Element Identifier. The next one is the fifth field. That's the total amount of SMS parts. If the original message is split into 2 parts, then this field is 2. If the original message is split into 100 parts, then this field is 100. But keep your message as short as possible. The last field, the sequence number. It tells if the SMS is the first part, or the second part, or fifth part, or etc. Well, this is pretty much how you split the long message into several SMS parts. The recipient's device will recover the original message from the SMS parts according to user data header. In the rest of the video, we will learn the implementation. We will learn how to write code to split a message. Now, let's modify this demo application. I'll give you a link in the description so that you can download the source code. If you don't know how to import the source code into Eclipse, you can go to the fourth lesson. Here's the source code. I'm going to replace the message content here. So I'm going to make up a message whose length is 141, only one character more than the limit. Look, this chunk of text is 141 character long. Copy this text. Change the content of the short message. Let's modify the SMS sending logic. Hold the control button on your keyboard and left click on this method. First step, let's split the short message. This is the one that we need to act on. The good news is we can use an external library that splits the message for us with only one line code. Each SMS part containing 140 characters. Let's download the library from this link. Find out the downloaded file. Here. Drag and drop. Copy files. Add a new library to the build path. Now we're going to split the message. We can use this method to do it. The method takes two arguments, arg1 and arg2. But what on earth are they? Maybe we should take a look at its definition. Hold the control button and click on the method. Can't really see the exact source code here, but it's enough to find out what I need. Here, we can see the first argument is binary short message, and it's a byte array. The second argument is reference number, and it's a byte. Back to the code. The first argument is gonna be this. The second argument is byte type argument, ref num. The reference number can be any integer between 0 and 255. So let's define a random number that falls in that range. Import the class. Then we're going to use this method. Which returns a random integer between 0 and a certain value. In this case, that's 255. Let's call this method. So far, we used this method to split the long message into parts, housing the original message. I need another variable that stores SMS parts. Now we've split the SMS. Let's see how it looks like. I'm interested only in the message splitting for the moment, so I'm going to disable the interaction between the program and the SMS sender. This one as well. Save the file. Set a breakpoint here. Then debug the program. Let's take a look at this variable. Look at the original message has 141 characters. The index from 0 to 140. The original message is split into two parts. The first part takes up 140 bytes from 0 to 139. The second part takes up 12 bytes. Let's look into each part, especially the first 6 bytes. Then make user data header. In this example, the first byte is 5, the second is 0, the third byte is 3, the fourth byte is the message ID or reference number, which I told you is a positive number, but this negative number is just a way of displaying. As long as the byte value is within the range, it's fine. Eclipse presents byte as a signed integer, but we can still see the unsigned integer. Click here, Java, then click Java Preference, then click Primitive Display option. Then tick this. Then in the square bracket, you'll see the unsigned integer. This 2 means there are 2 parts in total. This 1 means the first part out of 2. Other bytes are SMS content. For instance, this 65 is actually letter A. Let's also display it. There is a setting named Primitive Display Options. Enable this one. Alright, you see these letters? These are user data header. They are displayed as some strange characters. Alright, this is the first SMS part. The second part is similar. The first 6 bytes are user data header. These 4 bytes are identical to those of the first part. See? This means total number of SMS parts is 2. This is the second part out of 2. This is the message content. So far, we already split the long message into several SMS parts. Next step is to send them one by one. I'm going to use a for loop. Now I need to make some changes. Normally, we use this method to set short message. It takes a string type argument, but what I have is a byte array. What should I do? In fact, we can use opensmpp library. It has a method that takes byte array as input. Let's go get one. From this link, here, let's add it into the build path. Drag and drop. Copy files. Let's add it into the build path. We'll be using this jar, and we're no longer using this one. So remove it from build path. We need these many external libraries in this lesson. Now let's fix the errors in source code. All I need to do is import the classes again. I'm going to delete all of these. Import the session class. Import the connection class, but not this one. This one instead. Look at the package name carefully. Keep doing the imports. This one. Okay. Save the file. The errors are gone. We're changing libraries, changing imports. I'm doing all of this just in order to call the method setShortMessageData. This one. I mentioned it once in the 7th lesson. Now we can learn now how to use it. It takes an argument whose data type is byteBuffer. So I need to do one more thing. I need to convert the byte array into byteBuffer, so to speak. Import the byteBuffer class in this package. Then call this method. You have a byte buffer that contains short message data. Finally, enable the interaction between SMSC and the transmitter. Enable this line of code as well. Save the file. Let's do some tests now. Let's open up the SMPP sim. I stored it here. If you don't know where to get one, you can check out the first lesson. Before turning on the SMPP sim, make sure it's configured properly, such as this SMPP port. Another thing is, ESME to ESME property, set it to true. At the same time, set loopback property to false. Save the file. As always, configure transmitter properly. Like this IP address, I can change it to this, because I'm just testing on a local computer. Save the file. One more thing we need is an SMS recipient simulator, which you can get from this site. Go to release. In this lesson, we're using the very first version. Click here to download. This is the directory that contains the SMS recipient simulator. Before using that, let's check some configurations. Look at this configs. System ID, password. Looks pretty familiar, right? They have to be consistent with the SMPP sim settings. Here, like this system ID, password, SMPP port. Also, this phone number has to be the same as the destination address. Here. So let's make sure the transmitter sends the message to the right recipient, because the recipient is supposed to receive only what belongs to him. Save the file. I guess we have pretty much everything ready now. Finally, to make the code look nicer, I'm gonna format the source code. Got some indentation here. See? Save the file. And let's test. Turn on the SMPP sim first. This one. Then turn on the SMS recipient simulator. This one. Hit the enter button on your keyboard. When you see this line connected to SMSC, we're ready to do some tests. Now, let's run the transmitter. We can notice here 2 SMS are submitted to SMS sender, but in the receiver, it's definitely not what I wanted. So what is missing? What is the title of this lesson? It's ESM class. Until now, I haven't mentioned it once. It's an SMPP parameter. As always, let's find some information from the technical documentation. There you go. Let's search ESM class. Here are the possible values that the parameter can take. Among all these, you see this UDH indicator, which means user data header indicator. Let's see. The spec says when the most significant bits are 0, 1, the UDH indicator is enabled, no matter what the rest of the bits are. In other words, if ESM class take a value in between 64 and 127, then the 6th bit is set, which means UDH header is enabled, which means the SMS part contains user data header. In addition, ESM class is 0 by default. So, to solve our problem, we need to call a method that sets ESM class. This one, the input is byte. The value is in this range. By the way, not all values can be used. You still need to look into documentation or communicate with your provider. But 64 should work. Alright, save the file. Let's run the program and see what we'll get here. Everything looks fine in the transmitter. Receiver also looks normal. Why don't we take a look at the receiver's log? Here, it's in this directory. This is the latest log. You can see from the date modified. I'm going to compare this message with the original message. This and this are the same. So basically in this lesson, we've learned to send a long message through concatenated SMS. First step is to split the long message into several SMS parts. Each part contains user data header. We can use this method to do it. Then we send out the individual SMS parts one by one. Remember to set ESM class for each part. If you call this method a split message, you have to import this library beforehand. Also, you need to call this method to set ShortMessageData and remember to import this jar. In addition, we've learned the concept of concatenated SMS. Finally, you need to know that the SMS part discussed in this lesson is 140 byte long. Maybe you want the length of each part to be something else, like 160. In this case, you have to modify the implementation of this method. You can have a look at the source code at this link. See? That's it. Hope this video helps. Thanks for watching. Peace.